All right, we know there are different ways to prove a triangle congruent. We know it by side, 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 angle, side, angle, side, angle, and what? Angle, angle, side, right? So we have 4 ways to be able to prove a triangle's congruency. We're going to use those to be able to prove a triangle is congruent. Let's take a look down here a little bit. We're given that line AB is parallel to DC. So these 2 lines are parallel. We are given that angle B is congruent to angle D. These 2 are congruent. We want to prove that line BC is congruent to DA. How are we going to do it? Let's take a look. It says, in this case, we know that these are parallel. We know that AC forms a transversal, right? We're used to transversals. We've used them before. All right, and we know that angle BAC is an alternate interior angle to DCA. So we know that these angles right here, this one is congruent to this angle, and this one here is congruent to this angle, right? Per our alternate interior angles. Okay? You have 2 pairs of congruent angles, which I showed. We just went through. Because we know they share the side congruent to itself, you can use angle, angle, side to show the triangles are congruent, right? Angle, we got a side here. We can go angle, angle, side. We can also use angle, side, angle, can't we? Angle, side, angle. Angle, angle, side we can use. All right? So we know that those are congruent. All right, it says here, then use the fact that corresponding parts are congruent to show that BC is congruent to DA, and here's the proof. Okay, first we have given. We know that this is given. We know that AB is parallel to DC. That's a given. We know that angle BAC is congruent to DCA, and it's by alternate interior angles. We know that angle B is congruent to angle D because it's given. All right, we're setting this proof up. By the reflexive property, line AC, right, is congruent to CA because it's the same line, isn't it? Okay. So we know that by this, we know that we can, this could also be angle, side, angle here, by the way. We know that triangle ABC is congruent to CDA by either angle, angle, side, or angle, side, angle, because we did it here. All right? Therefore, if my 2 triangles are congruent, that third side on the triangles must also be congruent. So BC must be congruent to DA. BC, DA. These sides have to be congruent if these 2 triangles are proven congruent. So what have we done? We've used triangle congruency to be able to figure out that all the sides are congruent. All right? And you can use it by, you're going to use, in your proofs, you're going to use these to be able to figure out your congruency. If you can show one of these, then you know the sides and the angles, right? Not just the sides, but and the angles are congruent too. They're the same triangles, and that's how we'll prove it. I don't think you guys have much to do on this one, to tell you the truth. Let's see, we've got a proof here. And I think there's 2 and 3 on the other side. Well, look how it's set up. What's given in here? Write in what's given. All right. And here, we know that side MO equals MO. Why? It's a reflective property, right? Congruency. You can use top. What's the next thing you have to figure out? Figure that in there, and then do 4. And be able to prove this. Let's take a look at 4-4's second one. This proof is a little bit longer. Just call me Mr. G. Okay, this one here, number 2, go through definition of a median. You know what definition of a median is? Splits it in half. You know what a midpoint is? All right. PT is L2. I want you to do number 2. I want you to do 3 and 4. 4 problems. 4 proofs. And I will be checking them tomorrow.